Okay. All right. For the recording sake, welcome team for cohort 6 of GenAI training, Agentic AI. So we will be going through the introductory session today, the first of 16 sessions, 8 weeks, as we discussed about. We'll talk about the GenAI, the components, and then what we will be covering in the coming weeks. And we'll dig deeper into the what LLM is, what are the models, and all the landscape is. Out of the 16 sessions, we talked about almost 13 plus sessions will have a hands-on demo. Only 2 or 3 sessions will be more like fundamentals. This is one of them, the first session. So tomorrow we'll definitely get into seeing at least some of the demo side of it. So, but today it will be pure understanding the landscape of GenAI and what it is about. Okay, so let me share my screen. And okay, I guess everybody's able to see my screen.
Yes.
Okay. So before we get into this question, what is your perception of GenAI? What it is and how it is helpful, how it is going to shape anybody? It'll just take 5 minutes to generally discuss because we all know bit or a lot about GenAI. That is why we are all here to learn more, understand more, benefit from it. But I want to understand what is your perception of what GenAI is, how useful it is, how it is going to impact us. I'd like to hear from Ravi. Ravi is very knowledgeable. I think he's just back from AWS reInvent, right, Ravi?
Yes. I'm sorry, yeah, I came back yesterday.
Okay. Okay.
Yeah, there's some new announcements around Cairo or Kiro, whatever you call it.
Mm-hmm.
That was the main topic they were talking in the keynote.
Sorry, your voice is not very audible. What is it, Ravi? Can you come again?
So at the keynote, the main importance was around Kiro or Cairo.
Cairo. Okay.
Yeah.
Okay. So what is it about? What is Cairo?
I'm on a platform where you can build everything, right?
Uh-huh.
And for a start,
AWS, it's
yeah,
not
for
like Bedrock and SageMaker
everything,
like that.
everything, yeah, yep.
Okay.
It's a new platform.
Okay.
Apparently, for startups, we get 1 year of free Cairo usage.
Okay.
That was announced recently.
Mm-hmm.
Yeah. Majority was around agentic AI.
Agentic, yes.
Yeah.
Yeah. Okay, before we move on to the other people, right? Yesterday at my office, CBRE, we had the people represented, which is from Covio. I know most of you must have known. Covio is a AI-based search engine that powers a lot of applications. They've been doing this AI on the browser, right? AI-based search engine for years now. So they were there yesterday, and they are also talking the same thing. Yeah, we are doing agentic AI, we are doing MCP, we are getting everything into the browser. So every other company we talk about, every other last week or couple of weeks ago, I think MuleSoft was there at our office. So because we use a lot of all of these, we are using all of these products at CBRE. And they come to share the roadmap and all of that, right? So it's kind of meeting. So so a few weeks ago, MuleSoft was there, and they are talking about the same thing: MCP, A2A, Agentic AI. So these are the 3 terms we keep hearing from everybody who's coming and sharing their roadmap for every product. And these are not even AI products. They are just like ERP products or marketing applications, middleware or UI. But still, even they are talking about just the agentic AI and MCP. That's all they talked about. That's all about 25 and 26 is all going to be the key buzzwords, right? MCP and agentic and MCP basically. Okay, Surendra, we want to hear from you.
Yeah, so from what I understand, Gen AI is for generating content, obviously, automatically through AI by given some prompts. Not sure what the application would be, but that's what I know with Gen AI. And Agentic is where more for customer service kind of AI services. Yeah.
Oh, nice. Yeah. Somebody who's not talking, can you one? बेहतरीन कनेक्शन हुआ और स्वेरलिक की तरफ गया बॉल स्वेरलिक hearing some commentary cricket, I think. रोहित शर्मा के सामने ये जाते ही जो स्वेरलिक बिल्कुल के ऊपर दर्शक है वो नहीं हो जाते हैं शॉट लगने से पहले ही ये फ्लाइट आईवी सो में एक से क्या okay. All right, great. Somebody's on iPhone, but hearing about cricket commentary. Nice, good start to the day. All right. Hema has already been a Java champion, and she's an architect at Comcast. So she's been doing ML and AI for a few years now. I think she is into Gen AI. So I want to hear from Hema the what things about AI and how they are also applying it at their workplace.
As Surendra mentioned, it is a tool to generate new content based on the huge data that is trained to the models and the questions asked by the users by making it simple, human understanding for public use.
So great.
We
Okay.
are content like text, voice, images, etc. Based on the prompts or questions asked by user using Gen AI tools.
Okay. Great. So what I will do, I will straight away skip to the last slide here. Then we will come back. Right. So let me share this. What are the use cases basically where we are trying to apply or get benefited from generative AI? So generative AI will go from beginning, but I just want to give you a sneak peek kind of thing where it is actually being useful across domains. Enterprise knowledge work domains, we all know chatbots, right? So we have all been using chatbots for a while now, right? When you say first thing we think of any chatbot, what is the first use case we think of? See, customer support. That's the most popular, you can say first to adapt use case for AI. So whatever you see is little text box, you type and enter and you get response and then you type again. So that same bot, that application has been evolving right from the days of coding that in multiple conditional statements. We remember 15-20 years ago also it was there, but if you remember, it was more workflow based, and that workflow was completely written predetermined questions, set of questions you write, branching happens with an answer yes no, and as you follow those branches, yes no, you come to an edge node. It's basically node based, right? We call leaf, branch, node, and all of that. You keep writing this question. And there were many tools where even that was, there was a provision to configure that, create branch, add a question, then yes, no, you get two branches. If it is yes, what is the next question? If it is no, what is the next question? When you come to the end, there is an action there. So that is the first evolution or the first representation of an AI-based chatbot. Though there's nothing AI about it, it's more conditional based execution of the workflow. Okay, but that's the same Autobot chatbot. Sorry, you take, and we take the journey of that same application, and we see where we land up with the GenAI. So after the first condition based, you write all the questions. So there is a fixed path that it's going to take based on your answers. Now, when you exhaust all the branches, we come to the end node, there is an action. Okay. So the action can be, yes, the customer has got his answer, or the action can be you get connected to a customer service agent. Now, how did the customer get an answer? Because we have hard coded. If it is yes, hey, give this answer to the user. Now, where did you get that answer from? We just hard coded early days. Next gen, we went in, same thing, same questions. Now we integrated with our databases. So we wrote all our questions and answers. So based on that, we integrated to database, collect information, and then gave it to the user. But still branching going on, and then we click and then get. Third generation, we got customer 360 softwares, IVR integration, right, to this chatbot. Now, when you ask questions now, the entire 360 degrees view, we collect information from various data sources from internally. Basically, it can be finance, it can be previous tickets, it can be his products that he has bought, it can be the resolutions that were provided to him, the case history of that, what were his previous chat questions, and all of that. And based on that, you try to give it an answer. There's some bit of AI there that was introduced. Then it was automation, workflow automation. Based on automatically, you could take the next step and then ask the questions. Now, take all of that wrapped up, and then you introduce the Gen AI. Is basically, it is taking the question and the answer you get from all of your library, internally, whatever we talked about. There is a generative AI model or an agent or a RAG that you build that is providing you all the information of customer 360 within your company. And based on whatever answers you are collecting, the model is trying to generate an answer for the user. So there is no more if else conditions, there is no more branches, yes, no, whatever. Rather, it has become a interactive in nature. So you ask the question, the model will understand and respond, and the conversation can continue until a decision is reached. There is no fixed path that, hey, this is the end of the node, right? So you can continue the conversation with the model, and all the information is available to the model within the organization to answer your question. So that is the generative AI use case that has come to evolve these chatbots from fixed automation. So there is no fixed path now. So the model can decide to use any of the data to answer the question. If it is not, it can always go back to the first question again and then regenerate the answer. So there is no fixed path, right? And there is no unidirectional path. It can go back, go forward, go in loops, interact. It is an interactive in nature until the problem is solved, the user is answered, or there is always again an option to get you to the agent, the human agent, basically. So that is the first kind of use case that has evolved. If you take one use case and see how it has evolved over a period of time in the decades now where the Gen AI is used. Now, as we said, it is generative in nature, but generative in nature, we'll talk about, the limitations when we talk about the models, what it is and all of that, but where we are using. First thing, if you look at enterprise, right? You all know ChatGPT. You're asking questions, it is answering. Great. General knowledge, right? But as an enterprise, you are not in the business of providing general knowledge either to your employees or to your customers. You are here to answer some business specific questions, okay, or organization specific questions. So basically, you have to work with your organizational data, or a problem solving kind of application for the customers to help them. Okay, the customer will not come to an enterprise to ask what is the latest score in a test match, right? Or how is the weather in Bangalore today? You can, but you use ChatGPT generally for that, or Google for that. But if you have an enterprise application that you are providing, you are not expecting those kind of questions from your customers or your employees. So you are expecting more like, hey, what is the maternity policy at my company, right? Or hey, what happened to my refund that I have applied for when I returned this product? So these type of questions to answer, right? So it is all on the organizational data that is needed to work on, not the generic what model provides. So we'll come to that limitations in a bit. So first thing is document summarization. So you have huge number of documents, you want to summarize and provide a summary of it. So this is a very beautiful use case. We at our company, CBRE, we have actually created an application that has reduced the effort from 5 days to 2 hours. The use case is generating an RFP for customers, because we are commercial real estate. We respond to RFPs for the customers. There are about, the customers ask, it's a 100-page document or 40-50-page document. It has about 100 questions in there that you have to answer for an RFP.
Hello?
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 Yeah, Pradeep?
Yeah, hi Gaurav. Sorry.
Hello? I think he's talking to somebody. Are you guys hear me okay?
Yes, we can hear you. He's talking to someone else.
Yes, we can hear you.
Great. So we are I'm talking about the RFP application, right? So we are talking about a 40-50 page document that user sends, that I want to know all of this, what you provide against, what are your services, what are your capabilities, what is the best deal that you have done earlier, can you support this kind of requirements and all of that. So about 100 questions, 40-50 page document, and then you have to answer each of that question, structure it, organize it, prepare a presentation or a PDF or a deck to respond to that RFP. So this used to take the team about 4 to 5 days. So what we did is the document summarization is, we kind of took the RFPs, historical RFPs that we have responded to over a few years, like last 10 years or so, dumped it into a library, put it in a vector database. Then in the new RFP, we run through, extract all the questions from that, and try to get the answers from our previous 100, 10 years of historical documents that we have. We match it and we display it to the user. Hey, these are all the questions 1 to 100 in the RFP, and these are the answers. So all they need to do is review the question, the answer, and say, hey, this is good. You check it, or if you want to override, you override it, and then you submit. It generates a document and you're done. So at least the template is done in less than 30 minutes. Okay. Then you go back, review, restructure, add something, remove something. So the review process, human review, is always needed, right? So all of that will take less than half a day. So it's about like 70 to 80% of the effort that is saved. Look at the monetary, because of the time, right? So that time, if there were about $5 million of deals that were there, currently people are prioritizing the cases because they don't have enough bandwidth to respond to all of that. and then take the top deals and respond to that. But the smaller ones are left on the table. That's about $1 million. Now, because they can respond faster bandwidth now, so they can bring all that 1 million into it. So it's kind of you're getting a potential revenue generation for another $1 million. So which you were earlier leaving it on the table. Right? So that's one straight away low hanging fruit that you can get using the AI use case, right? So it's generating the documents from the existing historical information that you have. It is also used in the legal for, say, cases that you have. Historically, you have so many hundreds of these paralegals and other ones who used to research and get summary of the similar cases earlier. What were the judgments? What were the arguments, evidences, and all of that. So that can be done quickly now. In less than 1 hour, you can get all that summary related for the related cases that we have and the best strategy and all of that we can in the legal. You have internal Q&A, like I talked about, hey, what is my maternity policy, right? So all HR related documents. So right now also you have Confluence, you go and check, log in, go through all of that hierarchical, click, go to benefits, go to HR policy, go to maternity, and then go there and read all the document and figure out. Now using AI, you put all your HR related documents as a library, and then you create a RAG application chatbot, and you give access to that library. So the customer can ask any question. It will go through all that library, fetch it, and give it to you. You still have something like that in Confluence and also, but it again gives you a hyperlink to that particular document where that is mentioned. It's kind of crawling through your documents and giving you the links just like Google. But with GenAI models, they go through the document, read it, and summarize it for you. What is the policy kind of a thing? So co-pilots for analysts and legals. Legal is what I talked about. For analysts, like code generation, also you can software development. If you see here, code auto completion, code generation. What we are using, Anthropic, or we are using Copilot is very popular, or the AI-based IDEs like Cursor and a lot more have come in to help with the software development. Customer engagement, we talked about support. Healthcare is one of the domains that is very, very heavily benefited because the drug clinical research, drug discovery has been accelerated, I don't know, maybe 100,000 times because of the processing and insights that AI is providing, which earlier was not possible. Okay. So these are all some of the use cases, not all. But as I said, it's going to be cross-domain. It's going to touch every domain, every workspace, every application. So AI is going to be there in some form or the other. It may be a pure play AI application, as I talked about, or it may be an assisted or somewhere helping you in your current workflow automations or anywhere in the entire data journey or applications. Okay. Any questions here? Anything you wanted to add with respect to use cases that you are seeing at your workplace, or what you think it is, how it is using? We'll go back to the first one. Okay. Any questions, anybody? Are we all good? Okay. All good. Yeah. Okay. Give me 1 second. Deepak is here.
Hi, Arun.
Okay, I saw your message. You said you are not able to join.
No, I joined. I got the link later.
Okay. Yeah, fine. All right. So we'll talk about this agenda. We are, I think we set up the platform, what we're going to talk about. Evolution of Gen AI use cases is what I touched upon very lightly. What I have covered the use cases is only 10% or even less than 10% of what AI is going to do, going forward, right from autonomous driving cars to all the way to space, right? Everywhere it's going to help reshape the perspectives of how we look at these domains. LLMs, what is an LLMs? What are the different types of LLMs? Domain specific, who are the providers, what they provide, what are the components of an LLM, what is RAG and what is Agentic AI. So we'll touch upon all of these in this session today. And then we will move on to the next ones, deeper. So evolution of Gen AI. So when did you first hear of Gen AI? Anybody? When did you first hear of Gen AI or LLM or generative AI, whatever they call it?
Machine learning I have heard in, I think, 2017.
Machine learning. Okay. Yeah. Couple of years back. Yes. So I remember.
I heard mostly 2 years back, Gen AI term.
2 years
Around
back. Okay.
2023.
20. Okay. So I remember sometime, I think 22 September, that's when ChatGPT was released. GPT 3.5. That's when the whole world kind of went berserk, looking at the generative capabilities. The first time somebody was seeing that it is generating a code based on the prompt that you give. And that's when it kind of exploded. The visibility and acceptability. Now somebody it's came out to entire world that, hey, there is something powerful that's happening in the world of AI. Even before that, yes, the work was happening early from 1960s on AI, where just creating a machine that can do a task of a human being was generally termed or coined as an AI, right? So you have a computer, it's supposed to be it's mimicking human tasks, what we do, calculations or some kind of that stuff that is helping, keeping the records, keeping the ledgers, basic Windows, basic all of that. Over the years, we have come to machine learning, which is a algorithms that learn from data, trained data, which is more statistical approach. The scientific approach to do some kind of machine to make machines learn what humans do. Most machine learning algorithms, as I said, are statistical in nature and used for use cases like prediction. Okay, we have prediction, we have classification, we have clustering, we have recommendation. So these kind of use cases were mostly adopted by ML. So basically you have let's say, a real estate industry. You want to know what would be the price next year. You want to predict the price at certain location. Now, how do you predict? It's not astrology or palm reading, right? So machines predict based on historical data. So you give, hey, this is Bangalore, this is Delhi or whatever city, and historically this has been the prices of the land or real estate, and this is the location, this is the year, this was the price, but the context is missing. All it can understand is only numbers. So you say this, and then there is a price that is predicted. So it will fit based on all of these, the economic growth, the GDP, the number of companies that are coming into that particular location, the development that's happening, the per capita income, the weather conditions, geopolitical stability, all of that. Based on that, historically, it will see how it has been performed to try to predict what it will be in the near future. Okay. Or let's say I want to predict a demand in my yeah, AI fails in Bangalore. So let's stick to, say, Dallas market, right? Girish, I think that should be good. It can, yeah, I think it should do a good job and it's predicting. So when say if I have a store and I want to predict what will be the demand for meat or vegetables because they are perishable. So I want to order only to order a particular amount. What would be my, how much I would need. So again, the factors here would be, is it seasonal? Is it winter? Is it summer? Is it holiday season? How is it going to be the weather? Right? And how many will be the footfalls, or is it a holiday? Is it a long weekend? So all of the, and what is the, again, the demographics, which area are you located at, what is the mix of the population there, and all of that, and what is the income group around that area. All of this play a pivotal role in coming up with an algorithm to predict what will be the meat demand that I would need for the next 1 week. I need to order, or vegetables, or say restaurant, how much food I need to make or keep ready, right? If it is holidays, there might be more people. Weekends, there might be more people. Weekdays, there might be less people. If it is seasonal, the demand will change. So all of that will play a role in kind of building those algorithms. So all of these are statistical in nature. So as I said, it has and recommendation engines. This is another use case machine learning has been addressing for a long time. If you say Netflix, based on what you watched, what is your recommended next kind of a thing. Or online shopping, you see all relevant ads, what you based on your browser search history, or what you have purchased earlier. So all of this has been fed to your machine learning algorithm and then try to predict similar items, similar products that it can recommend to you, kind of thing. Okay, and classification. So binary classification. Say for example, cancer cell research, cancer cell. You send it to biopsy, or you have a cell, benign or malicious. You want to identify. Of course, you can do a lot of biopsy and then get that. But historically, say you have the data of particular cell across multiple dimensions, like the weight of that tumor, the dimensions, and whatever features it has, and then there is a classification. It was found to be benign, or it was found to be malicious, cancer or non-cancers. So you have a data for say 1 million earlier tests and results, and then you give a new test to it based on the historical information it has. It will try to fit this into the pattern recognition, right? And then see decide whether it is a malicious or benign tumor. So that kind of classification, true. Or say customer churn. Hey, this is the customer pattern. Would you stay or would he move out? Say for telecom companies use a lot, for this churn, right? Whether the customer will stay with us or he will move out of us. So that is algorithm that they use for machine learning algorithm to use to predict based on the past historical data. So past that, we moved into DL neural networks. Neural networks is basically it's just like our neurons, millions of neurons that are connecting. Each one goes through the information, passes it on to the next one, adding some information, weights and biases, and then filtering through all the information, and finally you get an output. So DL mostly came into visual recognition kind of a thing. How do you process an image and understand an image, identify an image kind of a thing. it is used with advanced with machine learning, which is called deep learning with neural networks, and to come out with weights and biases neural networks to come and recognize an image recognition, and several tasks that ML cannot handle can be done with the deep learning kind of a thing. So all of these have been used for us to build a generative AI. The next more thing is generative AI. It's already built on all of this. So these models are trained on all of these machine learning, deep learning, and NLP, natural language processing. So natural language processing, as we know, that's what GenAI is all about. It can generate an answer in a natural language that you can understand. It's not trying to copy the exact data from somewhere and give it to you. It can inherently generate the data. It can generate text, it can generate images, it can generate code, right? So that's where it's called generative AI. But how does it generate? It's trained on using these ML and deep learning and your NLP, all of these algorithms with the data. What kind of data? So machine learning, when you see, it is trained on a specific data. When I talk about I'm building a model, these are all static. If a machine learning model, I'm training it for, say, cancer cell classification, it will only run, it will only be trained on that data. It cannot predict anything else. It cannot predict the real estate prices. Okay. Deep learning also, if I give an image, it does. So what GenAI does is it's trained on all the available public data, huge data. So it becomes generic to answer anything that is available, okay, public. But again, it's built on any of these algorithms. So it has an algorithm that runs and then it produces an answer, a text or image or a code. So DL was basically to identify an image, capture images and all of that, and reading the text and understanding the image as text, like numbers. If there are as an image, it can extract text from the image and all of that. But GenAI has went one step further. It's not just recognizing an image; it can create a new image based on what it has learned from all of these images. So it's all more like generative in nature. However, there's still the machine learning and deep learning part of it that's still there. But GenAI is like more generic. When we talk about any job descriptions, when we apply for jobs, you see most of it like machine learning and GenAI, because these are two different machine learning, deep learning, NLP, they put all of that. But two different branches of AI that is used in enterprise, GenAI and machine learning. The use cases are pretty different. Okay, you should first understand what use case fits my AI or what use case fits my machine learning. As I said, if I just want to predict my meat supply in the store, I'll be more benefited from using a machine learning model than using a generic LLM model. Okay, but if I want to summarize a 100-page document to give a one-page summary, I will be benefited using LLM model than trying an ML model. There is no ML model for that anyways. So you have to first understand what kind of use cases that fit either machine learning or GenAI. So which one to go? Normally, I have seen most of the use cases, people are just trying to say AI first or approach AI adoption approach. So they're trying to fit everything into AI, even though it is not, right? Forcefully trying to put, as I was saying, you take a jar of pickle and you put it into a jar of sugar. So once you open the sugar jar, inside you're still gonna have pickle, right? So it's basically, you have to understand, whenever you talk to somebody, you have to be very clear. What you would do is first you do an analysis of whether it should fit a Gen AI approach or you should take a machine learning approach. And you would know once you go through GenAI what kind of use cases we do and what kind of things we do, right? So going through that, so generative AI is branch of AI that creates new content such as text, images, music, code based on input prompts. Okay, whatever you write, even earlier you were doing with what you call Stack Overflow or Google, you are writing your question there. The same thing you call it here as a prompt. Okay, when you talk to any of these LLM models. So it can generate text, it can generate images, music, and code. Basically, you have models that are very specific. I mean, different types. Some models can do text, images, some can do video, some can do audio. So there are different models that are developed for different things. Okay, and from each platform. Unlike traditional AI models that focus on classification or prediction, GenAI generates novel outputs using techniques like transformers and generative adversarial networks. So these are the techniques that are used by the models to generate new outputs. Okay, it's not trying to classify or predict something on the historical information, but it's trying to generate new information. So this all started that 22 ChatGPT or the evolution of the models. It all started with a research paper called Attention is All You Need in 2017, which introduced transformers that paved the way for large-scale models like GPT, Generative Pre-trained Transformer, or Bidirectional Encoder. This paper, what it does, you can also look at the paper and go through it. What it meant was, earlier, these NLP, all of these NLP models, they were processing the data sequentially, one word at a time or one token at a time. So they cannot preserve the context of the entirety of that conversation. Now, attention, all you need what gave me was, you can process parallelly all the tokens. Let's say if a sentence, you process the entire sentence parallelly, each token in the sentence, and figure out how each word is related to each other. And that will give you the context of predicting what the next token will be. Okay, so when you are typing in ChatGPT, once you write one letter, it will give you an option for the next 3 letters, 3 words. You can select one of them. So it's predicting basically that when I say how, the next word it predicts is are. Okay, or is. So sometimes you type how are you, or sometimes you type how is it going, right? So are and is, it has, from the training, from your past data or the trained data, it has understood that whenever there is a word called how, there is a probability of having these words, are, is, and everything, whatever, right? Now it will give you an options. You just touch on it and it goes there. The moment you say select are, then it will give you another 3 words. What could be the next word based on that sentence that you have? Now it's not just taking are, to predict the next. It's taking both how are. So what is the probability of having any of this word? What would be the word that would come after a sentence that has how are? Okay, so then probably it will say you how are you is the probability of getting a word called you after how are is about 90-95%. Then let's say how are things at your end. Sometimes in the conversation we use that, how are things at your end. Then just say how are you, right? And then whatever it is, irrelevant conversation, right? How are the classes going? Now in that 3 sentences, the next token or the next word is different. So it's going to give you all 3 options with the probability. So that's how the AI models predict the next token. The word we refer to here as token. So it it predicts the next token with a probability based on the context. Means, hey, I have gone through 100 documents, 100 passages, and most of them, when there is a how are, 90% of the times I see a word called you after this. or how are things. I see things at 40% of the times. So it will take those probabilities and predictions and take the one with the highest probability, and then it adds that word there. Now let's say how are I selected things. Now if I put how are things, then the next word, it's predicting on the combination of all this paragraph. Now how are things, then it will predict what could be next. It can be at your end, or how are things going, whatever it is, right? So that is how it's going to predict, because the attention is on all the tokens at a time, not just the previous token. So that's the way this research paper from Google in 2017 that has changed this entire AI platform. So to come up with more powerful models like this, generative pre-trained transformer models. Okay, so that's how the AI or a model is generating. It's always predicting the next token based on the context of the previous tokens. Okay? And then it picks up the most probable token to generate. Any questions on this? No questions? Can we move forward? Okay. Okay. Yeah, you're good. So we move forward. Now, what is a large language model? Anybody want to give any large language model you think of?
Yeah, ChatGPT. It is one large language model.
Okay. Who's that? Sorry, I didn't see your name.
Prem.
Prem. Okay. Yeah, ChatGPT. Okay.
Yeah,
Yes.
Gemini. All these are like LLMs.
Okay. Okay. So ChatGPT is not an LLM. ChatGPT is an application. It's a
Okay.
chatbot basically. Okay. I know it's
Okay.
synonymous because that's the first time people came to know about AI, Gen AI, and LLMs. So just like we say search engine is Google, the same thing, a trained model with large sets of past data. Yes. Okay. That's right. ChatGPT is a application or a chatbot which connects to an underlying LLM to get answers. So whatever question you ask, it sends to the LLM model, large language model, and gets the answer for you. So just like a wrapper around, to communicate with the LLM models. So LLM models, yes, large language models, which are trained on huge sets or all of most of publicly available data, with all of these machine learning, deep learning, and NLP algorithms, because it is trained on huge data and it has capability to think and generate answers. It's very huge, takes resources both in terms of money and processing. So that's why there's NVIDIA, they have a lot of demand for their GPUs, because these AI models need a lot of processing power to process all of that publicly available information to train these models on using all of these algorithms. Plus, so that's, and you need a lot of money, of course, to process that and train that data. So these large language models, as they're trained on all of these algorithms and data, they're capable of analyzing your question and answering it with the context, whatever context you have, right? And then you can continue conversation. It will remember what it has done previously, what answer, and then you have a conversation with it, just like with a human agent. Okay. So these are trained on huge sets of data, as we said, publicly available data, and each platform, as I said, GPT, right? So OpenAI has their own set of models, and Cohere has their own set of models. Anthropic has their own set of models. Google has their own set of models. So these are models that they have created and available for everybody to use. I mean, commercially or open source, whatever it is. Now, in an enterprise, you use these models to build your applications. That is your GenAI applications. So what are different types of LLMs we'll go through, but here they are pre-trained. What we need to understand is an LLM. When you talk about an LLM, it's a model, okay, that is trained on massive text data sets that can answer the questions, it can understand and generate an answer based on its knowledge of training that it has. Examples: set GPT-4, GPT-5 from OpenAI, Claude from Anthropic, Palm Llama from Meta, Palm, I think, from Google. Don't remember correctly, but yes, just some of the examples. We'll see more here. What are the capabilities? They can chat, summarize information, they can generate code, they can generate images, again, all of that, audio, video. Limitations, yes. So hallucinations and lack of citation. So what do you think are the limitations of a LLM model? This is very important to understand because that's where the entire industry is heading to solve these challenges of models. So what are the limitations of LLM, or shortcomings or disadvantages of LLMs that you think of? It's good they are answering everything. Okay, security, hallucinations, not up to date.
Decision making.
Decision making. Okay, decision making. What else? Citations have improved a lot, yes. Yeah, I mean, that's what over the past 3 years, all these industries are, an industry as a whole, data compliance is heavily focusing on solving these challenges because that is the most important thing for adoption. Now, I'll tell you about a year and a half, like 2023, I went to Databricks Summit, and yes, they're not fit all use cases. Correct, Surendra. The data and AI Summit, Databricks, the only focus for GenAI for them was the adoption. The adoption of AI was like less than 20% or 25% of the whole use cases. Even though they were trying very, very hard to push adoption, not just Databricks, all organizations, it's been less than 25% or less than 30%. When I meant adoption, from POC to production. If you take 100 use cases that you do POC, only less than 15, 20 of them go into actual production. So that is the rate of adoption is very low, right? That's what is the challenge. So why it is very low? Because not because it's not working, but because it does not fit the use cases, like Surendra said, right? Because of the challenges of the limitations. What are the limitations? First thing is hallucination. It has been improved. So I'm talking about early 22, 23s. They used to hallucinate a lot, right? Even if they don't know an answer, they used to predict some answer. Sometimes, most of the times, wrong answer, which is not even there, fictional, completely created, right? So that's very dangerous for enterprise. It's okay for creative purposes, but for the enterprises, it's very dangerous. Then lack of citations. As you said, yeah, it's improved a lot now, but earlier it cannot tell you where it got that information from. Like if you go to Google, it only gives you information what is there. It does not give you anything. It gives you options. Hey, these are all the things I see related to your question, you click on that, go to that resource or website, go read it, figure it out yourself. I am only here to help you show, hey, these are the available resources. But LLMs will give you an answer very confidently. Hey, this is the answer for this. Okay. But you don't know whether it is true or not. If you ask them, it doesn't give you citations where it has seen that answer. So the trust was very low. Right, that's one of the challenges because it could not give citations, it hallucinates a lot. Security, yes, that was another thing. It used to give out information left and right, whatever you ask for. So it is very dangerous to put it in a production environment because you don't know what information it's going to give out. The personal information, security information, prone to identity theft, fraud, all of that, right? So when you say phone numbers, emails, SSNs, healthcare information that you have. So it was, again, one of the challenges that it's going to face. Of course, it has limitation again with the knowledge, right? So let's say model GPT-4, GPT-5 is released in say, January 2025. Now this is December. It does not have information what happened after January. So if I ask any question about what is the highest temperature this year in Dallas, it does not know because it does not have information after January. So to solve that challenge, of course, yes, we came up with, providing it, giving it some tools, equipped with tools so that it can go and the model can go and search the internet and then get the answers and then give it to you. That became, that wrapper later became evolved into an agent kind of a thing. But that's one of the challenge. The other challenge was, remember when we said it is trained on massive text data sets, the key word here is publicly available. As I said, of course, going back to our question of what is the FMLA policy or what is the maternity policy or what is the sick leave policy for my company, it's not a publicly available data unless the company chooses to publish. So the model is not trained on that. It does not have information on that. It can give you some generic thing. But if you're talking as an employee, you want to know your organization. So the model has to connect internally, look inwards, and get the information from your company's database documents. That's what we talked about, right? Building a RAG. So we solved it using a RAG architecture to give that information with tools and the models. So these are some of the challenges. Now, most importantly, why the adoption is low is LLMs are indeterministic, which means this is the most important thing you should remember, should talk about, right? Whenever you talk about anybody who says why, what is your take on AI, why Gen AI is not getting the adoption as it needs to, or do you think it's gonna completely take over everything, replace everything? The main challenge of LLMs is they are non-deterministic, which means one, they generate information. They're not giving you exactly what is there. It's going to generate something for you. So it's never going to match what you have already. It might be close, but it's not. Second thing, the same input. So wherever you test any application, you write test scenarios, you write test cases. You write in a test case, this is the scenario, this is what is the expected output, and this is the actual output. Now you pass the application when all your scenarios pass, meaning your actual output is matching with the expected output. Matching in the sense exact, right? The answers. When you have a Gen AI application, that's never possible. Your expected output, your actual output can never exactly match your expected output because it is generative. It might be similar. The same scenario you run twice, you get a slightly different output. You don't get the exact output. I'm sure if you ask ChatGPT or any of it, but yeah, they're trying to fix that. That's different story. So the non-deterministic nature, where it says the golden rule, right? Basic rule of any application, any software is you give the same input, you have to get the same output, which fundamentally is broken with the LLMs. You give same input, you're not sure you will get the same. You will get similar output, but not the same output. So that's one challenge. Now put this into a scenario of a financial application. You are asking some finance related question, numbers, right? Salaries or tax or whatever. And then it's giving you different answers every time. Would you trust that application? No, right? So whenever there is numbers involved, wherever you need accuracy, in finance world, you get accuracy decimal points to third, fourth, sixth, eighth decimal, because when you multiply billions, there will be a lot of difference, right? So in that scenarios, the LLMs fall short of it. So that's why the adoption is very low in terms of in where a financial application is involved. So those are the challenges, and the security, of course. Where you're sending information to a model, or is the model using it for its internal training, or is the model it's completely secure on your network? Of course, all of these companies say they're not going to save it or use it, but there's always some kind of security issues. Like you can always override LLMs, just like SQL injection. We'll come through, what is called guardrails, how you protect your information, how do you sanitize your input and output that's going to LLM. We'll talk about all of those guardrails later. But that's one thing that you need to look at. So this is challenges for the LLM models, Gen AI for adoption. Okay. Hallucinations, indeterministic nature, security, lack of citations, most of it indeterministic nature. So most of it has been tremendous improvement over the years to make it deterministic, like same input to get the same exact output. Very recently, I think this is done some of the times using the caching mechanism, where you don't go to the model every time. Once you get an answer, you save it and then respond from it, instead of getting to the model again and again, because the number of tokens will also get you charged. So that's one thing that you can say. Plus you get the same kind of answer when you do the caching kind of a thing. But all of these players who are training and getting these models, they are getting this better, so that the hallucinations are now reduced. They are getting built-in guardrails. Not that, of course, you put it on top of it, but inbuilt also, you get some safety nets, right? Blocks. So now the LLMs does not answer any questions that it feels it should not. Like more recently, they said children asking about some topics, right? So there was a huge concern that AI is trying to answer the questions which it should not, about suicide. People are asking so many questions. It's giving advice on all of those, or health related advices it used to give. Now they are restricting, building the guardrails that it's not going to give any health advice or any of these psychological issues or questions that and that's it's flagging it basically. So those things are the guardrails are improving a lot, building into this, but then they have to still, there is a challenge of indeterministic nature that they need to solve for better adoption. But having said that, as we talked about, the use cases which are most benefiting are the creative ones, say marketing and sales, where it's very creative in nature. So there's no personal information involved or any of these things. So that's where the adoption is very high, to create campaigns, to create images, to create audio, video, visuals, marketing, sales, decks, pitches, advertisings, campaigns, and all of that. That's the most adaptive, benefited. Legal, healthcare research wherever that is, it's definitely helping, right? And code generation, basically all the IT, all the there's a lot of hype about replacing all the developers with the AI, but I personally don't think that's going to happen in immediately or very near future, because it's going to backfire. We have seen some of the cases, like, yes, it can generate code. Now it is generating tons of code, but if there is nobody who understands that code, you are very soon going to land in trouble. If something goes wrong, nobody knows who's going to fix that. Nobody knows what that code is, right? So it's still, we're still not there yet. I still see many years down the lane that might be, but not immediately. As I said, right, Jensen Huang and NVIDIA CEO says, like, AI is not going to take your jobs, but the people who know AI will come for your jobs. So it's super important for everybody to know, understand how to use AI in their day-to-day work. So yeah, coming back to this models, right? All of these limitations are already there. But models, if you see each vendor, there is some Q and text to image. When you give a prompt, it will generate an image. Of course, I think you all have followed the Ghibli trend and other things that on OpenAI it ran for some time, where you give a prompt and it generates an image, or you upload an image and then you want it to change the pattern and generate it in a different uh, pattern kind of a thing, right? Context. Or text to audio. Text to audio, you've seen some of the computer generated voice reading out the script kind of thing. Audio to text is already there. So whatever I'm talking now in the Zoom, if I record, there is a uh, conversion, the text that is generated from the audio that you display, right? The transcript. So that is already a kind of audio to text model that is working for you to display the conversations. Text to image, text to audio, text to video. So Runway, ML, Pika Labs, Imagine, VO2 from Gemini, so Midjourney. So these are very 11 labs. These are all very popular models that we use for this. But in enterprise, we use mostly the text-based models. But as I said, in marketing and sales, it depends on the domains. They use a lot of these audio, video, and image kind of models that they generate. Have you ever used any of these models other than ChatGPT? So if you look at these companies that provide their own models, right? So Meta has this series of models, Llama, Meta Llama, Llama 1, 2, 3, whatever series they are. Anthropic has Claude 1, 2, 3, Haiku, Sonnet 3.4 or 4.5 is latest. Google has Gemini models as well as Palm models. OpenAI, we know GPT. I think GPT-5 is the latest in this. Amazon, Titan text, Titan embeddings, Grok, XAI has Grok. There's DeepSeek and other parameters also. Other platforms, companies that are providing the models. Now, each company can have different types of models. They can have one text model, they can have one audio generation model, video generation model, like Sora. Sora is from OpenAI, which is a video generation. Veo is from Google for video generation. So text models, there are different. Image, there are different. Multi-model, multi-language, multilingual, they are different. So each company has different offerings in different categories of models. Okay. So if you want to go and check, so let's say Google Vertex AI. Okay. So every Google Cloud has blocked. Let me go here and do this. So every provider, this was just Google, right? The same thing applies for Amazon, which has Bedrock or another studio, Azure AI Foundry, or Databricks or Snowflake or any platform. They will have all of these models that are available. Some are hosted, basically their own model that they have created. For example, Google's Gemini model, or they host the models from other vendor. It's like, you're buying an iPhone. You can buy from Apple, or you can buy from T-Mobile or AT&T. So they can sell you iPhone. They can also sell you Samsung. Okay. But here, Apple does not sell Samsung phones, but I'm just giving you an example. So Google has its own models, but they also host models from other vendors. So they can use even those models also on their platform. Now, if you see here, there are Google models, 119 models. So in that, if you see categories, right? Image classification, there are 27 models. Object detection, text classification, entity. These are like categorized, very specific things that you can use a model for what you are looking at, what feature that you want. If it is just text generation, there are 78. Image text embeddings, so image retrieval, video classification, radiology, there are like something. So these are domain specific. We will come to it. See, there is text to speech, there is audio generation. Okay, so if I click on text to speech, in text to speech, we have these models where Anthropic two models, Claude Opus 4 and Claude Sonnet 4. So these are two models from vendor called Anthropic, but they have hosted it on Google platform. So we can use it here. And there is something called SysM CSM. Okay. Now, if we go to text embeddings, so we'll talk about embeddings probably tomorrow. If you go here, things. So these are all available for generating the embeddings. We'll talk about what is embeddings tomorrow, but just I'm giving you all of this. So let's say we'll remove this and then go to text generation. We know radiology. See, there is MedGemma, MedSig LIP, CXR Foundation. So these are three models that you can use for radiology. Say SIG-LIP variant that is trained to encode medical images and text into a common embedding space. So let's say you are analyzing the radiology images, right? So these models are helpful in analyzing those images. There's a use case that I have recently read about radiology, right? So people think like AI is going to replace people, but it kind of talked about how it is generating more jobs there by simplifying things. Say, for example, if I have a doctor and I have a radiology, and the radiology can process 10 reports in a month, or 100 reports in a month. So the doctors now can only prescribe 100 people for the radiology or MRI scans, because that's the capacity. It's just like an industry, right? Capacity. Now let's say the capacity has increased. Now using AI, they can process 1,000 reports in a month than 100. Now, are you just going to remove all the radiologists, or now because you have 1,000 reports, you can process, you can subscribe, help more patients with the reports, with scannings, because now the capacity is increased. Now, since you are doing more reports, there are more jobs that are created. You need more people to analyze that. AI can only give you the reports, right? There's somebody who's need to understand and read and document and write reports. So he's going to generate more jobs there because you're doing more production now. You're using more now. So by simplifying, it's not reducing the jobs, it's actually helping create more jobs because now we are doing more. So that's true for anything, right? Even industrialization. You said people manually can create 4 shirts, but if you use automation machines, you can create 50 shirts, but one person cannot process all those machines, right, to create 50 shirts. Then there's more people that are needed to generate, because the production is now increased. Now you need more transportation, now more processing, more sales. So everything is increased because now you're able to do more using this tools. So yeah, that's a little off track, but so if you, long story short, so these are foundation models for so radiology. You have, again, for pathology, for dermatology, these are like very domain specific for each role. A model is trained on that particular subset of data. So we'll come back to that in a minute, what this. Text embeddings, text generation, so all of these models. Now, if you go here, image text classification. So there is Claude, so many models. There is Meta Llama models here that you can use. There is Mistral models from Mistral called Woodstral, Small, Jamba, Imagery. DeepSeek is here. Quen is here. And then there are, again, Biomed, image classification, zero-shot image classification with biomedical vision language. So very specific, domain-specific models. But, and then you can fine-tune the Llama models, text-specific. So all of these are text classification models that are available. Okay, so if you look at Google models, so these are basically from Google within that text classification. So these are kind of, you can use models. So if you go to, say, just you want to go to OpenAI models, I'm just going API. See here, you have GPT 5.1, 5 mini, GPT 5 nano, that's one. All of these are the models from OpenAI. Okay, so specialized models they have here. Sora is video generation. Okay, Sora 2 Pro, audio video generation. And then for deep research, O3, O4, image, cost-efficient version of GPT Image 1. So we have bigger models, we have smaller models within that. So based on DALI 3, previous generation image generation model, this is deprecated now. Speech to text model is mini transcribe, when you want to transcribe from speech to text, things like that. Audio models are here. GPT audio, audio mini, real time mini. These are chat models, GPT 5 chat, 4. So basically, so many models that OpenAI has to use. Okay, and then there is embeddings if you see here. So similarly, text to speech, general purpose, text only, embedding, all of that. And then you have here concepts, code generation, image, which models you can use for what. So similarly, every platform will have their own models that you can use. Any questions here?
Question on the Google models. I don't see OpenAI. So that means they're not official partners with Google?
Yeah, I mean, they are not hosted on it, but you can always use your APIs to connect to models externally. So there are some owned models, hosted models, external models, 3 different types, right? So let's say you are using Oracle database, okay, and you are on AWS. AWS does not have, hosted Oracle. You can always connect to your database from AWS and get your information into AWS. Or you have an API external, so you can always connect. Yes, whatever Google has hosted, you can use. If it is not, you can externally get that. Yes, Azure has most OpenAI collaboration, so they have all their models hosted on Azure AI Foundry. Google might be different. They have their own Gemini models mostly, and then some Anthropic and Claude because they are generic. Okay. Let's get back here. Okay. Now, so what are the parameters of the LLM? We'll again come back to this tomorrow. So there are a few parameters whenever you access a model that is going to, it's kind of levers or tunes, buttons that you can tune your interaction with the model. So what is the model size? So when you look at any of these models, you will see 170 billion parameters or 100 billion million parameters, 700 billion parameters. So it started with a few 100K parameters. It went now all the way up to billion and trillion parameters for the model, which means it has so many factors that it processes before generating a response. Okay, it's like different paths it will take to evaluate your question. Parameters is prompt that we do. No, parameters is not the prompt. Parameters is what the model is trained on, what it consists. It means if a model is 100 million trained, it will consider 100 million parameters or paths or options or the paths that it evaluates before it gives you an answer. It looks at 1 million parameters before it answers your question. If it is a trillion parameter, it has to look at trillion combinations or trillion options or paths that it has to evaluate before it answers your question. So basically, the more the size of the parameters, the more complex it is for the model to respond because it has to do so many computations. The total number of parameters in the model influencing its computational complexity and capacity. So basically, when you ask a question, how many computations it does before it gives you an answer. So that is the model size, its parameters. Now, you can also look up, I encourage to look up, go to each side and then say OpenAI model parameters or size, right? So if you look at, see, clip is 115 million parameters. GPT OSS series is 20 billion and 120 billion parameters. Okay, so these will tell you actually the complexity of see models here. OpenAI 115 million, this is 76 million, 175 billion, 117, and GPT-4 1.76 trillion parameters. Okay, so which means it's a key model capacity with more parameters, meaning greater capability but higher computational cost. It has to compute all of those parameters before it answers your question. That is why the compute is higher, the complexity is higher, the lag is more, the time takes to process and respond is more. So basically, when you select a model, you have to select based on what is your need versus what size you need. So if you're just trying to summarize a document, you don't need a 1.76 trillion parameter model to answer your question, to do the summarization. You can go for a smaller model with smaller parameters, which will cost you less. For processing, though you are not processing, the provider is processing, and then the number of tokens will be charged based on how much cost the provider occurs to process your tokens. Yes, Girish. You have a question, Girish? You're on mute if you're talking. Hello? I'm sorry. I can't hear you, Girish. Yeah. So that is the parameter. Called the model size. Now the context window is, so how much of your conversation can be persisted. So you're having a conversation, you're asking follow-up questions. So how much of the previous conversation the model can remember, right? So it has to answer holistically. Okay. So if I ask, hey, what is the temperature in New York today, right? So it gives you some answer. Then I will ask, what is the wind speed there? There means what? Now it will go back to check what is the previous question, its answer, reference, context we call. In which context are you asking this question? So I'm asking, what is the wind speed there? There means it will go and check, oh, previously what we are talking about. So he's talked about New York. So probably he's asking the wind speed in New York, or precipitation or rainfall in New York. So it will go back and answer that question, keeping the previous question in context, the New York in the context window. Now, how long can you continue the conversation? How long can it remember your previous questions is your context window. Even this has come up very improved a lot. Initially, it was like few MB. Now it was like characters, like 1,000 characters or 10,000 or whatever, 1 MB kind of thing. Now it has gone up to the 120 MB. So you can have huge conversations with the LLM in the context window. Generation parameters, you have temperature, which means from 0 to 1, where the 0 will give you focused results. And if you go higher, it will give more creative and varied outputs. Basically, we would always love to have to put 0 in enterprise, but in domains like advertisement or marketing campaigns or sales or creative fields, art, music industry, they want to have more creative and more varied outputs. So they can change the temperature to look at various things and answer. Whereas if you put 0, it will be like specific to what you asked, only to that level. So that's one parameter you can set when you are interacting with the model. Model size and context window are fixed. When you take a model, they are fixed for that model. But temperature you can keep changing when you want based on your interaction with the model. You can set that, it's a configurable. Max tokens is basically what is the maximum length of token the model can generate in response. Some have 1,000, 5,000, 10,000 tokens, whatever. And then this also you can control, saying, hey, I don't want the model to generate 10 pages of answer. I just want the maximum limit to be set to 1,000 tokens. So whatever you ask the question, it will only respond in less than 1,000 tokens so that you don't get charged for that. Presence, frequency, penalties, like based on, again, the model gets in the training itself. Do we, our model itself does this in the background to call right amount of parameters. No, so the parameters is not configurable, it is fixed. If you take a model, it comes with 1.7 trillion parameters, it's always 1.7. So as I was just explaining here, some of them are fixed. You cannot change it once you select a model, like model size or context window, you cannot change. Max tokens, you cannot change. But temperature, you can, it's configurable based on your, whatever you want, you can change it and talk to the model with that temperature. If you're seeing very creative or varied, not relevant results, you can reduce it to make it more focused. This is configurable. Penalties, mostly it's again during the training, not in your control. But you can specify sometimes, say, let's say stop sequence. If the user sends if you see a pattern of characters of words, you can ask the model to stop responding. If you look at some patterns, if somebody is trying to sabotage your model, if you identify that patterns, you can ask the model to stop generating text. So you can put that sequences. If I send this, you stop generating that. Top K, top P will limit models to considering only the top K most probable next tokens during generation. I was talking about it, right? When I say how are is the sentence, now what is the next word it has to predict? It will predict based on the probability, but it will take some number of options. It will take, say, 5 words or 10 words. Then it puts probability on all of that and then selects the top probability one. Now, the top K will tell you how many tokens that it has to consider even before putting the probability on that. So you can say 3, you can say 5, whatever. But it's all about the model. It's trying to generate how many tokens and then put probability kind of a thing. We don't see direct impact of that yet. Okay. So top P is again distribution of token choices, how the probability distribution is happening internally with the model. So these are some of the parameters that you should be knowing when you do the what is the. I'll take another 5 minutes and then we wrap up. I think we have discussed a lot. So domain specific LLM, I have already talked about. So this is how my teaching goes. As we talk about, I don't strictly follow the sequence or read out from the text. As and when the context comes, we'll discuss, but then it will reinforce it here, whatever the points that I put in the text. So it is what is a domain specific LLM is, yes, the model you have trained on, say huge data, 170 billion parameters, and you have trained on all the available data, and it is very generic, it can answer anything. But let's say I am a broker, okay, a finance broker. I am only interested in knowing the market research for finance related or the share market. Why would I need a huge model, 1.7 billion trillion parameter model that can answer everything? Rather, I would pick up a smaller model which can answer only to a specific area, domain, right? So that's where the domain specific LLMs have come, which are almost like SLM, we call small language models are also there, which are focused and they can perform better, answer better for that domain because they have been trained on that domain, data information on that domain. So there is a what are the domain specific? See, if you see here, Bloomberg has its own model that they have trained. They take the base model again from Llama or GPT, whatever, and then they retrain it on the finance data so that it performs better, specifically trained on financial data to perform tasks like sentiment analysis, question answering regarding to the stock or performance of the companies. MedPalm is like healthcare, built on Palm and trained on medical data to excel in the medical question answering. So if you have any medical related questions, this will give you more specific, accurate answers than a general GPT kind of a thing. So there is a Kai GPT, domain specific language. Harvey, this is for the legal research, more trained on more legal terminology, legal answers, questions, cases, and everything. Financial reports. So like this, most of the vendors are now taking off the shelf these models and then training them on a domain specific data and packaging it and offering as a commercial product for that particular domain. Okay, so fine-tuned, trained like finance, law, or medicine to excel in that area's unique language and knowledge. I mean, even the ChatGPT can do, it's generic, but these are more specific kind of it. They perform better and they have only one specific task to do. So they obviously perform much better. They are trained on data relevant to specific domain, allowing them to learn domain-specific terminology, concept knowledge, improved accuracy, contextual understanding, and tailored outputs. Okay. General use cases we have already talked about. So what are core components of AI that we are going to learn? So LLM we talked about today extensively. Of course, that will be part of every session because that's the heart, that's the engine, brain, what you call, heart or brain of the all Gen AI. Then we'll talk embeddings, vector databases, RAG, and agentic AI. Of course, we haven't added here MCP, but yeah, that is also there. So these are all the core components that we will be talking about. So we will continue from here, just about what is RAG and what is multi-agentic RAG, just the pictorial representation of all the use cases. So we'll continue tomorrow. We'll talk about what happens when user asks a question, what it goes to the large language model, it gives a response, what is a prompt, what are the different types of prompt techniques, how we should improve your prompt, improves your response and all of that. And then we will introduce the RAG architecture and components tomorrow. Okay. So with that, I come to a closure on this session. I'll open up for Q&A. Any questions? We'll talk about maybe another 5 minutes. If you have any questions, then we'll get. Okay, Surendra has asked a question. How does the pricing work for consuming these models? Model size is not directly related to the pricing, but of course. So I'll show you the example here. See, most of the pricing is done. I'm sharing my screen or no? Let me share my screen back. See, pricing is done on the tokens. So tokens says if you're sending a question to the model, what is the number of tokens you are sending and what is the number of tokens that it is responding. So based on total count of the tokens, you are charged. Okay. So how many tokens? It says 5C cost approximately 0.01 to 0.17 for images. Let's see, OpenAI API pricing. It's based on the model you choose and the tokens. So if you say 5.1, now the complexity or the number of the size of parameters is indirectly impacting you based on the tokens. So the same number of tokens for this model, the price will be different. For this model, the price will be different. See, if you are using 5.1, which is a huge, big model, 1 million tokens will cost you $1.25. But the same 1 million tokens, if you are using a smaller model, GPT-5 mini, will only cost you 25 cents. It's 5 times cheaper. So that's what I said. When you are just want to summarize a document here, would you use mini or you use 5.1? So that's based on your use case, you have to take that call, right? So I wouldn't need a 5.1 to just do a summarization, right? 5 mini will do a cheaper version for well-defined tasks. This is for code generation.
The difference is because of parameters, right?
Sorry, second.
So that difference is because of parameters.
Yes, the size of the model is obviously the parameters, right? So how it is trained on, because any input you give here, it may have to just do 1 billion parameters processing. This will have to do 1 trillion parameter processing for the same question if you change the models. So that's why the processing is more here, the charge is more here for the same number of tokens.
So
Okay.
is there something like we can put a cap? Like I don't want to spend more than $100 for all
Yes, you
whatever
can.
work I'm doing. Or
Yes. So you get an API license. Sorry, you get a subscription, right? API. You put a $10. It just like works like your prepaid SIM card. You just put $10 on it, and then you keep it. It will keep deducting from that on the API. So once your $10 is done, it will say it will throw error. It cannot respond. Enterprise is different. There are different types of engagement models, right? So enterprise can be a license for the complete year. Unlimited tokens might be one or whatever it is. But there are different types. But for personal use, you get an API, you put some money on that API, and then you can. So it has all of these models. So when the price when the you can always top up your API using a credit card. Just so as I was saying, this entire training I use OpenAI API, but it will cost me less than $10 for the entire training I do. Because if you see here, even 1 million tokens is only going to cost you 1 million tokens is only cost you $2 output. Okay.
I have one doubt. Is there any possibility to control the output of tokens?
Yes, that's what we were talking about right here. One of the parameters that we have here, you can set max tokens.
Okay.
See here, max tokens. It determines the maximum length of generated text in terms of tokens. So you can restrict, hey, don't send me a response more than 1,000 tokens. So it will only try to respond within 1,000 tokens. So you only get charged for 1,000 tokens. They generally in the companies, they put that rate limit because they don't want employees just playing and with huge number of tokens, generations and cost, right? So there is some limit that they put in the non-prod environments for the token generation limit for models.
Thank you.
Okay. All right. Any other questions? Are we all good? How do you feel? So because this is our first session, as I said, some sessions are foundational, but 80 to 90% of the sessions will have a code also. As I said here, you will have, this is the structure, each session, you will have all of these. You have a deck, you have a code, collab notebooks that we run through code each session. So most of the session will have this, and then I will share the recording in the YouTube playlist. You will be accessed within 48 hours. By Monday, I will post everything. And so this will be the structure. We will go through each session. We will have both the deck and the code session also for that. Some places where it is UI based platform, there is no code session for some sessions, but it will be like UI based. So we will have the recording for that, how to create that workflow using the no code platforms. So as I said, right, so because this is the first session, do please send me your feedback either in the group or in a direct message, how you feel, the pace, the structure and the style, whatever. If you feel it's too fast or too slow, just let me know, or what else you want to see this. But as I said, it's too early. It's only one session, but when we get into the code sessions in another two sessions, you will understand more. You can give more feedback. Okay.
Quick question. The class Zoom events are coming in WhatsApp only, or you guys are sending us an invite and email?
As of now, it's only on the WhatsApp group.
Okay. And second, the link that you're sharing now, the cohort 6 or something, do we get a similar structure like this? Share it with us for each of the sessions?
No. So basically, this is, I will share the recording and the Google Colab notebooks also on the G Drive. Yes. Dex and G Drive, there will be a shared folder. You all get access to it. Yes, it will be similar to this. You will get access.
Thanks.
But only the recording will be on the YouTube.
Okay.
Okay. All right, guys. Thank you so much. Appreciate your interest and learning. Low temperature value means more accurate answers. Yes, Satya, that's right. Sometime model more tokens at the output, the time cost will be more. Yes, models will generate more tokens, Pradeep. But as I said, you can set that parameter so that it will only generate fixed amount tokens. Great seeing everyone. Please send your feedback and we will meet tomorrow same time to continue. Okay. Awesome. Thank you so much. Appreciate it.
Thank you, Haran.
Thank
Thank
you.
you.